First, I'm Pat Kennedy, City of Denver. Talk a little bit about hot in place recycling and how we use it in Denver in an urban setting. And I know, a lot of the people in this room are states, and you think, well, why do I need this when you're talking about it in an urban setting? But remember, your highways run through these urban centers, so this is a real good preservation technique that we've used in Denver. So I'm going to talk a little bit about how, what we have to look at, some of the challenges, and how we've overcome some of those challenges to have this be part of our arsenal of pavement preservation. So Denver, mile high city. Right now, I think even talking about maybe snow in the next couple days. So winter's coming. But just a little bit about us. Population little over 650,000. Street network, not the same size as a state network, but 6,000 lane miles. And when you look at our budget and you start to do some of the math, when you looked at some of the math yesterday, state agencies have like $8,000 a lane mile to play with. We work out having about $4,000 a lane mile annually to work at our network. But you can see here the hot in place, and we try to do a pretty well-rounded set of different treatments, trying to do the preservation in the right way. But in hot in place is about 25%, so it's about 1/4 of what we do is a hot in place recycle. We're fairly compact. Again, we're not spread out. This is a typical paving program that we do. I think this was the 2014 paving program, and I know it's a little hard to see, but the green that you see, and it's kind of a swath that goes across the middle, those are neighborhoods we did with hot in place. And if you dig a little deeper, there's also arterioles and collectors. So we use it for all classifications of streets within the city, and we use it as a mid-level treatment. It's if you look at the condition level of the streets, if you're in the real good condition, we're going to do the chip seals. If you're real bad conditions, you're going to be doing mill and overlay or reconstruct. So we need something in the middle, that sweet spot in the middle, to extend the life of a lot of these pavements. And that's where hot in places come into play for us. So again, minor treatment, good street, this one would be a candidate for a chip seal. All we're getting is some minor cracking, thermal cracking, some longitudinal cracking, but no structural problems with the roads. This is the major treatment. This is one where the street's hosed, and this is one where if we do a 2-inch mill and overlay, we're probably in the dirt. These streets were built with maybe 3 inches of asphalt originally. So in the middle, we've got some block cracking, a little bit of alligatoring starting to show up. We've done crack sealing in the past, but structurally it's a sound pavement. It needs something to extend the life of it, and that's where hot in place fits with us within our scheme. So the unique considerations that we have to look at. First, traffic control. It's the same as any other paving job. The paving train is about the same size. There's nothing special that you have to do for traffic control. If you've got residents and businesses to maintain, you can keep them open just like you would a mill and overlay job. The paving train will run through an intersection at kind of the same speed that a normal mill and overlay would go. So there's no real special needs for traffic control. You do have to look at what you're doing with what streets you're going to select, and this is from a geometric standpoint. This paving equipment, it can't take tight corners, it can't turn around a cul-de-sac or anything like that. And one of the other things you want to look at is kind of a uniform width. If you got a street that's going in and out for turn lanes and everything, they can do it, but it adds some complexity because this equipment is not like a normal lay-down machine where you can throw your wings out. It's compact and moves along. So you want to look at something with a uniform width, but again, state highways tend to be more uniform width as well. And you want to look at your cross slopes as well. The one thing about the process we use in Denver is we've got curb and gutter in most locations, and you want to match that again. So we're going to come through an edge mill. And so we're going to set and just take an inch off right at that gutter lip and then zero out the milling machine on the other side. So we're just doing an edge mill on that. So we're not taking anything out of the middle of the road. So the milling process is much quicker, much less impact to the neighborhoods then. But also what we're doing then with that process, when they're coming in with that heater and scarifying, and then we're laying another inch on top of that, we come back in, that extra inch will bring us back up to where matching the gutter. But in the middle where we haven't taken anything out, we're raising the street an extra inch. So two things to look at. Well, one thing to look at is the cross slopes. If you've got streets with a real high cross slope to begin with, you might want to look at doing full width milling. But the benefit of not milling is we're adding structure to the street out in the middle. Because of that, you know, these streets, again, that maybe only had 3 inches, now we're coming back and we got 4 inches on the street. So we're getting an extra benefit of adding some structure to that pavement. So when you get a neighborhood like this where you've got those tight streets, you know, tight corners and stuff, maybe not the best selection. But this is a neighborhood that was done successfully with Hot in Place. And you can see there's a few, you know, smaller locations, you know, short runs, some tight corners. This one, it looks worse than it really is when you drive it. But it really works well for Hot in Place. These nice long runs are good. They set the machine and they can go a half a mile and do a really good project inside these neighborhood locations. Vegetation is one of the things that people always talk about. What are you going to do? Because that heater and the heater scarifier, they will throw out some heat. But it doesn't take anything special to protect vegetation. You know, they'll lay some plywood up, they'll spray the tree down with water to get it damp beforehand. So it's nothing fancy. And I think in the 12 years that we've had this process, I think one little whip of a tree had to be replaced. But other than that, you know, occasionally some scorched leaves, but it's not a big problem with the vegetation along the sides of the roads. As a side note, if you're doing this and somebody has watered their lawn on something and there's a puddle out in the street, when that heater goes over the top of it, it puts out a cloud of steam. It's a steam bath. We've also used specialized mixes a lot. It's not something that you need to worry about. We've run SMAs, we've run asphalt rubber, and we've run asphalt shingle mixes. And I've got some pictures of how those work. So specialized mixes are fine. There's no issue with running a different mix through the machine. Arterioles, this is one that we did an SMA on in 2006. I think I took this picture in 2011 or 2012. So it's held up real well. You know, at that point, you know, you can see it's a 20,000 ADT. At the time I took this picture, it probably had 5, maybe 6 years on it. And on an arterial, you're usually only looking to get 10 years out of a pavement life anyway before your next treatment. So we're getting the life we wanted to see out of on a major arterial application. Here's another one where we used asphalt rubber. This one did not hold up as well, and it is not the fault of the process, because that year we tried asphalt rubber in several locations with several different techniques, and it didn't work out with us. Something about our climate, the rubber mix and the process we used did not work. So we weren't getting the life out of it, but again, it illustrates that you can use this process for all sorts of mixes. And here's one that we laid down, shingle mix, and this was a 515. It was 5% shingles and 15% wrap. And it's a good time to point out the mixes that we use. It's a standard. We're using a recycled mix all the time. That's our standard mix. So again, no issues with any of the asphalt that we're laying in with the process. And here, and it's hard to tell really well, but it's been edge milled, and then they're out here and they're just laying the mix on top of it. This is, you can see the existing pavement. There's been, you know, it's been crack sealed in the past, showing that typical block cracking thing that we want to do. That's where this process works for us. We have our own plant in the city, and this year I think we'll put out about 240,000 tons, which makes it easy because it's, you know, that helps both with their process, the Hot in Place, and with our own process. We don't have to wait in line to get mixed from another plant, so it's our production costs are lower, our wait times, hauling costs, all that are a benefit to us. So it's worked really well having our own plant too. Colorado asphalt producers didn't like it, but that's, you know, sorry for them. Life cycle. So like I said, an arterial street, you're usually going to get 10 years between treatments. If you got a heavily traveled street, lots of buses, lots of trucks, the best we're going to get out of a street is 10 years. Well, we've done, you know, here's a couple pictures of Hot in Place streets. One was done in 03, one was done in 05, and it's had its crack sealing. This is where you'd want to see a pavement after 10 years on an arterial. It's holding up really well. We don't have any issues with the life on that. And you can see the PCI 75 and 70. That's what you'd expect after 10 years. On collectors, same sort of thing. 10 years on a collector street, you're starting to see some of the longitudinal crackings. I would venture to bet this crack right here is probably over the top of a utility trench. It just looks like it. But again, you know, here's a street that's a dozen years old and it's holding up really well. Local streets, we don't know. It's, you know, again, we've used it for a dozen years. We're looking to get typically 17 to 20 years on a local street with a normal paving process. And here we are, you know, 12 years down the road, we're right where we expect to be. We have gone through and using our preservation techniques at 7 years, we put a chip over the top of them and we're extending the life. So it's worked out really well for us in that regard as well. So sustainability, certainly less disruption to the public. You don't have the whole milling operation going on, so that's a very rapid process. The smooth surface and IRI in a local setting it doesn't mean a whole lot. You're dealing with low speeds. I know the feds, you know, with MAP 21 and everything, they're pushing IRI is one of the performance measures. I've got issues with how to use that in an urban setting because you've got so many things that are in the way with manholes and cross crowns and utilities and warping a street when you're getting to inlets and stuff. IRI is not a great thing in an urban setting. That being said, when we go out with our low speed profile after projects, we're seeing dramatic increases into the rideability of the street. It's a very smooth process. And it's less raw material uses because we are using the top inch of the existing mat and heating, scarifying it, and then adding 1 inch to that. It's much less raw materials going into it, which means your trucking costs are dramatically reduced. Your, you know, wrap disposal, you know, whether it's going back into a mix or going to some other location or some other use, you have much less material you have to haul away from the site. So your carbon footprint just from a trucking industry is dramatically lower than you'll see with a standard mill and overlay job. And again, we're using 25% wrap in our mix. So when you're done with it, we've got a product that's over 60% recycled asphalt. You've got 1 inch of the existing road, you've got 1 inch of new material you've brought in, that's 25% wrap. And when you do the mixed math on that, we're running a little over 60% of a recycled road. So it's really sustainable from a materials use standpoint. It's on a typical mill and overlay job for us on a 2 inch mill and overlay, we're running about 800, 900 tons per lane mile, and this is using 400 tons per lane mile. So dramatic less material use. And so the economics come out pretty good. Less mill and overlay, or less milling prep, less reduced raw material, reduced hauling. So the cost for us is about $1 to $2 per square yard less than a mill and overlay. And that's what our main comparison is against a mill and overlay. So you're saving 6 to 10% compared to a mill and overlay. Doesn't sound like a lot of money until you're starting to look at a significant number of lane miles. When you're putting, several $1 million into this process, that gives you the ability to add 10 or 15 lane miles of paving a year without any increase in your budget. So a quick little chart that shows the economics, and these are the actual hard numbers where we calculated everything out, and you can see down in the corner where everything comes up, where that is compared to a mill and overlay. And that was using this, we were conservative in this. We said, all right, we're only gonna get 15 years out of the hot in place recycling. I know we're gonna get more than that. And using 17 years out of a mill and overlay. So even using a lower life cycle, which I think is extraordinarily conservative, we're still getting a very beneficial cost on it over time. So through history, so we started in 2002 and this goes through 2014. And we've got 2015 that I can add to that to the next time I give this presentation. You can see a fair amount of the city that we've used this process on. And some of this has come around for its next round of treatment. Some of it's still hanging out there and doing well on its own. So it's been a treatment we've used consistently throughout the city. Any questions?
Say that, same deal with that is your performance measures. States that use chip seals, you know, they may have 2 or 3 programs of chip seals on that before they bring us in. Have you seen any performance issues with the hot in place with the chip seals and mixing it with the in place hot mix material?
No, we haven't noticed.
Issues at all?
No, we haven't. And that's one thing, you know, we've used this process on streets where the last treatment was a chip seal, and that's worked fine too. We haven't had any issues with it. When we go out and chip it, it looks just like a mill and overlay job that we're chipping. So we haven't had any performance issues long term on that. Yeah, John?
Have you, it looks like in your pictures that this works really well for dealing cracking and anything. Have you ever used this where you had, say, intersection rutting at the traffic light signals, and if so, does it end up helping that process?
I don't know that it's any different than a mill, because we have ran it through intersections that had, we did one on 6th Avenue, which anybody who knows town, 6th Avenue is one of the main east-west arterioles in the city, and when it crosses the main north-south one, those intersections had rutted to where, cross-rutted to where it looked like a waffle, and we came through there, and we haven't seen any problems with the ruts occurring at a different rate than they had normally.
So you said have you tried to do these or do it next cycle, or how many?
Yeah,
how many
we
times?
actually there's a couple arterioles that were done as our pilot back in 02, 03. They've gone through and we've hot and placed those same streets again. So we've had 2 hot and placed back to back on the same pavement, a decade apart. We've chipped them over the top, and so their next cycle will probably be after I retire. So yeah, they're just falling right back into the normal rotation that all of our streets are.
When we did hot in place back in the 90s, we added some material to improve some mixed efficiencies and stuff like that, and mixed success. Do you guys do anything like that to add, increase structure or cross section or anything like that?
We've done, there's locations where we've done full width milling to help, just profile the street better. And sometimes just in laying the mix, we'll have it, just in trying to get the cross slopes back a little more, mix would come in. We haven't gone through and strategically said we're going to do a thinner section on a particular street. It's just irregularities will bring in some changes. But it brings up one point, that in doing this, we're taking an old street, an old pavement is essentially a dead pavement. It's 30 years old. It's gone through all of its age hardening. It's as brittle as it can be. When you're doing that, trying to do the testing, trying to do your QC on what your density is, that can be a little challenging sometimes, because that composite section, you don't know what the rice value is, and it changes from block to block because that's the nature of old pavements in an urban environment. So, we have to make some educated guesses on what your rice value is so we can come up with a density on it. But again, we haven't seen any performance problems due to lack of density or any raveling or anything like that. So.
How much investigation do you do up front? Do you do some cores to kind of see what your thicknesses are, or strip?
No, we know we have thin pavements all over the place. It's rare. The only place we find thick pavements is where there's an old utility trench. They tend to be thicker pavements than the rest of the street. So it's, yeah. But that's where it's beneficial in not milling that street out.
Excellent. Thanks for that.
All right. And so, Mary Gail, these pictures are from Montana.